Hi everyone, for this lesson I'll show you different functions. We'll define what a function is. We'll take a look at a t-table and the domain and range of a function. Okay, so let's first off define what a function is. So by definition, a function is basically a rule that describes a dependent relationship, right? It depends on something between two quantities. Okay, so again, a rule that describes a dependent relationship between two quantities, right? So that's the definition of a function, right? Alright, so let's take a look at the simplest function here. F of x is equal to 2x, say, right? Notice how I write f of x. This is written out in function notation, right? This is function notation. I'm giving the function name, the letter f, that's the name of the function. The input is the x, right? So this is the independent variable. Okay? And f of x depends on what x is. Okay? So let's create a function table, right? So, or a t-table. I'm going to put f of x over here, right? Think of it as just the y, right? So this whole thing, f of x, is the dependent. Alright, the dependent component, okay? So here, let's pick different values for y. Let's say, different values for x. Let's say we have x is 0, right? F of x is also 0 because you plug in the 0 for x, right? 0 times 2 is 0, right? Let's pick 2 for x. If x were 2, then you do 2 times 2, which is 4, so f of x would be 4. Okay, what about 3? Right? If x is 3, then it's 2 times 3, which is 6, so f of x is 6. As you can see, f of x depends on whatever x is, okay? And in this case, you just double it, right? So I can plot these points here, the corresponding points between x and f of x, right? This is, you can think of this as y also, if that helps. Think of this as just the y component, okay? So now let's plot these points, right? We have the first one here, 0, 0. That's right at the origin. Okay, let's label our axes. Actually, this is the x and this is the y, or in this case, the f of x. Right? Remember, it's just the name of the function. We're just giving it a name. I can call this function g, or whatever function I want to give, call it. All right. So here we have 0, 0. Right. Then we go. Let's plot the point. Oops. Let's plot the point 2, 4. So you go 2 over and up 4, and there it is. Right. So we have our 2 points here, and then our last point here is 3, 6. So we go over 3 and up 6, and we plot another point there. Okay. And if we did it correctly, it should lie right on a straight line here. Okay, and it does, so it looks good, right? And that's how you make a t-table, right, off of the function f of x equals 2x. Okay, and we're done with this one. There we go. Alright, let's take a look at another function. Let's call this function g of x, right? We'll make it equal to so g of x is going to equal x plus 1, okay? And we can easily make a function table or a t-table for this function, right? So x is the independent variable, and g of x will depend on whatever x is. So we'll do g of x on this side. All right, that looks good. Now we can pick numbers for x. We can say, all right, what if x is 2? All right, what's g of x? Right? In this case, you plug that 2 in there. So this is like saying, what is g of 2? Right? So wherever you see an x, you plug a 2 in there. And in this case, it's just 3. Right? Here, you just put 3 here. Okay? So now what if I plug in a 4 for x? Well, we'll just change wherever we see the x, we're going to plug in that number 4, right? So this is the x, it's 4, so plug that in there. So here's an x, we plug that 4 in there. So now my answer changes to 5, right? So we can pick the same color here. So we have 5, right? So 5 goes here, right? We can do maybe 7. What if x was 7, right? Again, this changes. The answer will change, right? So I can say, all right, x is now 7. So here goes 7 for x. Here's the x on the right hand side. So I'm going to replace that with 7. And my answer will change to 8. And I can plug 8 in here, right? And we can easily plot these points on a coordinate plane here, right? So let's clearly label the x on this side, okay? And the y here is the vertical axis, and x is on the horizontal axis, and it's always like that. And then now we can go ahead and plot these points. Right? The first one will be 2, 3, or 2, 3. So the x should go 2 units to the right and 3 up. Right? So it'll be right over here. Okay? And 4, 5 should be right over here. Right? And 7, 8 is right over here. Roughly right there. Right? What if we have, let's add a point. What if we have -1? Right? What if we have -1? Okay? Now let's go back and change my answer, right? Now it's -1 going into the x here, right? -1, right? Wherever I see the x, I put a -1 there, right? So -1 plus 1 will give me a 0, okay? 0 here, right? So we plot our point, so we go find -1. I go -1 to the left, and I go to 0, and it's right here. It's right on the x-axis. And I can easily make my line, right, to connect these points, right? You don't have to, but here goes. Okay, and there you have it, right? This represents this function g of x is equal to x plus 1, and we plot a bunch of points on the coordinate plane, and so we're done, and we're happy. Alright, so I use fluid math to create these 3 functions. One is f of x equals 2x, g of x is equal to x minus 2, and h of x is equal to x. And I'm going to plot them right on the coordinate plane here, okay? So what I'm going to do is just drag each function, right? So that's the first one. So that's f of x equals 2x, okay? Now what does g of x, what does the function g of x look like, right? So let's drag that in there, and we'll see. Alright, so that's the blue one. Alright, so that's g of x, which is equal to x minus 2. And then the last one here, let's see what h of x looks like, and that's the green one. Alright, so we have 3 functions right here, f of x, which was the red one, right? That was the red one. And then g of x, which was the blue one, and h of x, which is the green one. Okay, so we successfully plotted these functions onto the coordinate plane. Okay. Alright, so we have a very neat way to check to see if a graph is a function, right? And that method is called the vertical line test. Vertical line test. Alright? So let's say we have a graph. Let's say we have this here. And it looks something like this. Right? And we want to know if that represents a function or not, right? So all you have to do is draw a vertical line straight down. Let's do it right here. So we'll use this color here, right? If I can draw a vertical line and it crosses only at one point, and that's it. That's the maximum time that it crosses the graph, right? Anywhere I draw a vertical line, and it only crosses at one point at the most, right? And if that's the case, then yes, this is a function, right? So for this particular case, it is a function, right? Yes, this is a function. Alright, let's use the same vertical line test, but for a different graph here. Let's say we have this right here, and it looks something like this, right? Now we're going to use the vertical line test, right? We'll call it VLT for short, the vertical line test, and that entails drawing a vertical line. So here we go. Here's my vertical line, right? But something's different here, right? Let me highlight the spots. We have one spot here, right? We have one spot here. It crosses the graph at that point, right? So that's one. But it crosses at another one down here, right? So it crosses the vertical line crosses at 2 points, right? So if it's more than 1 point, then it's not a function. So this one result will be no, this is not a function. Right? And that's because the vertical line crosses at 2 points. It crosses at more than 1 point. Right? For it to be a function, it can only cross at most 1 point. Okay?